Welcome everyone to an amazing T2 Linux update here, the Linux distribution we developed for 25 years. And one of those things on the to-do list, and yes, as promised, my company Xrcode, supporting me even more than ever, committing here in huge investments, right, that I can work even more day and night. And another point from my to-do list finally implemented, and one of those I should have freaking done it a decade ago. It is finally here. Estimating build time, right? It is not more, nothing is more annoying. You build Linux on your 1 gigahertz Mango Pi, single issue and stuff, just some millions of instructions, and BTOP builds in 48 minutes and you don't know how long it will take. So given such cases like my Ultra Spark 5 or so, where stuff builds at least in 5 or 10 minute intervals, implementation details, so it's already committed, right? I implemented this the last days between my couch and a train and stuff. And what this does is now, if you, first of all, if you, so normally you would emerge, right? Let's start with a case here. For example, you want to emerge Valgrind. All right, I'm also not in the right. You want Tmax, sorry. I had rebooted. Usually I have my Tmax parked here, but I flashed some buyers and so if you emerge something like, okay, just emerge, let's do maybe a top, maybe not the best example, but let's pick something, because usually if we pick something random, some not perfect stuff happens. So also we want dry run. I will also further improve, I said it before, I will further improve usability, because I find it rather annoying that I have to use here dry run just to see what happens. And so the thing is, on a freaking Ryzen 750X, everything builds fast-ish. So 1 second, also this metadata might not be the most amazing, right? So you might wonder what is a big deal. Yeah, build time 1. Exactly was that? Maybe let's build time 3% of bin utils, and then it's like, yeah, still building in 1 second. Nah. If we build something more reasonable, like also bin utils, how much would it be? Hey, it would say bin utils would build in approximately 47 seconds. That is certainly like, let's not test with packages that build in 1 second on a Ryzen 750X. But even then it is usable, right? If you build stuff on Mango Pi or in not that much faster Raspberry Pi Zero or an Ultra Spark, you get the idea. So dry run. It would say like, hey, it's adding all the stuff, and hey, you would probably build all the stuff in 5 minutes and 5 seconds, plus minus, give or take. And hey, you can implement amazing usability and UI in freaking 25-year-old shell script. Implementation details a little bit tricky, and like I hope you enjoy this and learn something. It's even helpful for me because sure, I have an approximation of like, if I build LVM, it will probably take 16 minutes. That is probably a little bit off. Why is there so much off? Now we need better metadata. So this might be somewhat off, right? I just implemented it the last 36 hours. It didn't take, I implemented it in 2.5 hours over yesterday and today, I want to say. And the problem is that this is so dynamic and diverse, right? Between you build something on a single core and stuff and threads. I also tested this on an M1 Max MacBook on my desk there, and while it traveled. And I tuned it to be more accurate. So what are the issues, right? So we need some reference build time. I said it before. We referenced bin utils. Also, I also implemented that. Because the problem is, if you install a new T2, you usually don't build bin utils. So I also implemented now to guesstimate this based on the first package you emerge, right? Although it did maybe not instantly work the most amazing, because there might be still a tiny bug on that, because when I just used it on my 1750X here, it did not just work that detail. But so then the problem is, obviously it depends on your load, right? If you do this on a Steam Deck and you watch my YouTube video, that might be enough load on a Steam Deck that it influences the result, right? We cannot guesstimate what other stuff you run, right? And then the other stuff, so we historically logged the build time here, and we have not used it the most. Let's LVM, like all like bin utils, in this cache files, right? This is auto-generated, so cache bin utils should always have 100%, right? And then other stuff like LVM, what has that? Probably more than 100%. Yeah, that has more. Like, yeah, this should be 2055% relative to bin utils. Now, even with this, there is the issue. So, and this is actual user and system time. This is GNU time, like in user bin time, with user and system time. It always has been. So it accumulates. If I build this embarrassingly parallel on a 32-thread Ryzen, it accumulates that, right? So it accounts for all this parallel time. So it's not wall clock time, like so wall, the clock hanging on your wall of you time this with stopwatch. But it's accumulated user and system time, which is helpful for actually comparing parallel compilation with single compilation. However, it does not reflect by nature the wall clock time, right? Of like the wall we don't have anymore. What this means is, if we parallelize it now, like it would need, like if you like in terms of processing time, it needs that whether you build it single or multi-threaded. That is good. However, we do not know how much of the build time is wasted in non-parallelized single-threaded configure scripts, right? We could log this in some way. So logging that is difficult, but not impossible. Like very few things are impossible. I don't think it is worse. It is extremely complex to have somewhat accurate metadata of how much of this was running in parallel. You would also need an unloaded, like fully otherwise no background noise loaded server or so. So you could not build two things in parallel to properly log that, most likely. What this means for now, I have here, because initially I didn't compensate for that, and then even on my M1 Max MacBook, with running Linux obviously, the build times were way off, right? So I actually guesstimated that in function here of build time. The new function package build time, estimate package build time based on bin user reference time and cached build time. So I have here a parallel factor that I just literally 30 minutes before the live stream implemented here, and like 90% parallel was pretty accurate on my M1 Max with 8 threads on my Linux VM. But maybe that was not the most accurate. Maybe I should also debug all this stuff. So some of the stuff is implemented in GNU org, obviously, because math surprisingly sucks in shell scripting. I would actually, shell scripting would so much more amazing if some things would be more modern, like working with math, slug of all things. Let's see if we say what this means is like 80% parallel. Let's maybe check my formula here. So 80% of the build time is hopefully I mean, the thing is, it doesn't really fit for all, right? Like often in Firefox, it is not so. My goal is not 100% accuracy. That will be very hard. For that, we would need a per package parallel factor probably to halfway decent estimate that, but somewhat in the ballpark, I guess, is helpful and probably all we need. And welcome everyone. I hope you enjoy this and stuff and this helps you. This is, by the way, 2 times divided by 100 because the reference time is in percent and the build time, the reference time is multiplied by 100 just for accuracy. It historically was. It's probably like maybe like if you do fixed point math, don't really need this. And otherwise it is 100%, right? So divided by 100 again for 100%. This is why that is there. So serial build time integer of build time multiplied by 1 minus parallel, that is a single threaded time, plus build time multiplied by the parallel factor of 80% then, and divided by the configured parallel threads. All right, is also you. This is only as accurate if you do not overcommit your parallel build config, right? Like if you use less, that doesn't matter, that is fine. Like if you use 10 of your 32 threads, but if you just put the 64, this will not scale, right? We could very theoretically put there a failsafe, like if you manually configure T2 for a parallel max of 64 and you have only 32, this will be off by 50%, right? You get the idea. So yeah, let's see if emerge that was OVM, if that is, why is this at a 28? I think there's still something, probably some last minute, so probably I need to go home and go meditate a little bit more, because that is, or is the reference time somehow, can the reference time be somehow be that off? So now right now it says 28 minutes, I probably need to debug that. Didn't previously say something. 16, that makes no sense. Probably need to go back to the drawing board so much too. Showcasting this live on YouTube. Okay, I need to guru meditate this, something is off there. But in theory that is there, so it also shows the build time now. If you build something, like by the way, bin, let's try something that will be halfway on, and then I go home and further debug this. So it will now say here bash, this is new, and if the T2 scripts cannot estimate that, it will not show that, right? Let's see, this might be somewhat off. The build in 15 seconds, but anyway. This is of course, yeah, you improve something like a recurring theme of senior programmer improve something last minute and makes it worse. Amazing. But otherwise, that is a concept. There might be still some typo in there, as I just realized myself. I was so proud and happy. It was so halfway decent accurate on my 8-threaded or 8-threaded 8-core M1 Max VM and live on YouTube. It is off. Thank you very much. Well done. Yeah, patches welcome. In general, that is the idea. Oh, I will also further, as I mentioned or wanted to mention. So dry run LVM. I will also further improve emerge. I mean, we will gradually rewrite the whole build and emerge stuff. And what I will next improve is making emerge interactive, so that, because it's even for me somewhat annoying, I want to build something like I wanted to have something slightly different, including testing. So the first quality of life improvement here and usability improvement for emerge, in my opinion, is actually by default asking for the user, like putting out all the stuff and then asking simple yes, no, like, hey, you want to do that, yes or no? Because often I find myself like Control C, no, that is way too much, right? That would be the first thing. And then potentially maybe asking on a per package basis, like, hey, do you want to, like, not only once at the end, but in the middle, like, hey, you want this dependency or not? And also then obviously optional dependencies. I slightly wonder why this is like, let's maybe quickly check with bin utils. And then we call it a day. So bin utils right now also we want debs none for this test. And 1 minute 32, that could actually be, I mean, it should use bin utils as a reference time, so let's see. All right, by the way, if you build this verbose, it will probably even decrease performance by 1, 2, 3, 4, 5%, right? So let's not do this today, and then let's check the comments. And I hope you enjoy this and learn something. Question there, does it also estimate the build failure for me? Yes, it will, because bin utils failed on this, not super clean. Because like, why is this installation not super clean? Because I used it for some months of extremely embarrassingly parallel multitask T2 development. So there's always some little thing of I installed something and that had a shared file that I later fixed with like even bin utils shared files or slipelf or whatever the case might be today. And so yeah, it will estimate like, hey, it will probably fail on one. Like yeah, bin utils, yeah, sframe. I patched that, but the patch is not my system and I'm not touching that. So, but this was way off for some reason. Not really 32 threads. Why is this so much off? I mean, I tuned that. So it's using the reference time here, right? So it should have built, where is our, alright, default reference time 37. Let me think about that for, does that look reasonable? Alright, other, I mean, this is probably, I mean, we probably should scale the parallel factor to be accurate on, okay, this is still the same because we just built it. Do we still have the same here? Okay, no, we don't have the same. Let's restore that. We probably also should only update this reference time if it wasn't a build error. Let's quickly mess with this parallel factor and see if we can try run false. Yeah, 132. Let's quickly. What did I have there of? Okay, let's maybe 90% how I had this. 47 seconds. It's so small in the. Maybe 47 is. Yeah, 47 seconds. I mean 37, 47. This is so 90% is actually in the ballpark of where I had on my M1 Max. But LVM looks way off. That should be. I mean, it could simply be that the cache is not quality cache. So previously I updated the cache files for build time accuracy and for the dependency accuracy. Now we need to further update the cache files for build time accuracy. And then another complication was that, so previously we quantized this by 5 because 15 years ago when or even 18, like a long time ago in a galaxy far away, when I introduced some of the stuff at Rock Linux, I noticed that I do not want, like if I have a new build, I do not want to update all the stuff if just the build time changes by 1, 2 or 3, right? So I quantized this to 5 already for 15 years. And now, I mean, this was good for what it was supposed to be, it was okay. But now I realize a lot of build times are 0 because like if something builds very fast, like Lua or tons of other stuff, then build package Lua, it was 0, right? Because Lua builds so quickly and then it's like some very small number quantized by 5, it's 0, right? Like congratulations. So I added some, like not only so for the future I make the small build times not so now I dynamically quantize it. So for small build times, like by percent, like for single-digit percent, I don't quantize it. It will be 1, like quantized to integer. And then do I have a dynamic or quantize? So previously this was 5. Now it is here quantize for less cache update. You see, even the implementation details of something as simple are or complex. So now, all right, actually, yeah, I have here 5. Okay, so I misspoke. I misremembered what I implemented this morning. It's like, this is why you comment stuff, right? So if the build time is less than 5%, then quantize by 1. If the build time is less than 10, then quantize by 2. And this is just to reduce noise, right? I don't want to constantly, because like our data AI should update this, and I don't, like there should be some checks of like, is it useful for an AI nightly build server to update this stuff? Like, yeah, not if nothing changes, right? And what's better not to change if the build time is at least somewhat stable. Then less than 100, 5 like between 10 and 100%, 5 like it was. So that is compatible, so the numeric range is compatible to what it has historically been. Then below 500%, even 10, like I increased it further because realizing, hey, for very long, like it builds 15 minutes, we obviously don't need such a precision. So less than, up to 500%, quantized 10, and then 1000% 20, and even longer build times for probably Firefox or who knows what, like LibreOffice or Chrome. God forbid Chromium. like, yeah, quantized. Even this could be improved, right? We could round it better with adding here half of the quantization steps. Yeah, we could, like, if we wanted to for better precision, we could do. As this also means a lot of build times, and then I even added here, because currently a lot of build times are 0 due to the historic quantization. Build time 0 in all of, it's like here a lot of, as you see. So this are 2000, like, congratulations, 2000 packages, like all those modular X-render and stuff, like compared to bin utils, it compiles instantly. So it might not be 0, right? It might be 1, 2, or 3 or stuff. So the next build, due to the new dynamic quantization, it will be more accurate in the future, going on forward from here. And because we currently have 2133 packages for which we do not want to print 0, because 0 is obviously not very helpful, I default here to 3. So if the build time is 0 for historic reasons, then probably it's more likely around 3 than 0. So it's like, yeah, if 0, then build time 3, to have our stuff print out 3 seconds instead of 0, or if it's a Raspberry Pi, print out 2 minutes instead of nothing. So yeah, quite some details even in this stuff. And then of course I had to touch some output pieces left and right and so on, and do some testing and more testing. And although I did some testing, there might still be some bugs. Patches welcome. And that is, in my opinion, that is of course the difference. In retrospect, I should have done it 15 years ago. It was a low-hanging fruit, and I'm really happy to have finally done it. Thanks to my company putting even more efforts, as we read in a recent forward-looking statement, press release, of pouring even more money in our amazing embedded server, carrier grade and space-ready Linux distribution. And of course it looks much more amazing, right? And it's like emerge. Also, by the way, what did print Firefox? Like, hey, we would build your all this stuff in 21 minutes, right? It's probably off by a little bit, but it's like, hey, it's probably off by as much as Tesla self-driving car being self-driving. Fully self-driving. Can we scroll? So Firefox, to be fair, this Firefox, so this number is pretty accurate. 30 minutes, this is actually like so much to, hey, this code is not too bad, right? It's not full of, totally full of bugs. It's like, hey, I implemented and tested it for 3 hours. So yeah, that is pretty darn accurate. Not everything might be as accurate. But again, also, by the way, if you think this should be printed slightly better, should we add there some wording like built and estimated, like should we add there some English word of estimated and M for minutes, or not even abbreviated minutes, but spell out minutes, leave me in the comments below. Patches welcome. This is just a quick hack of today's work. So far, I would say this is pretty good. I think for now I leave it there. Alsa-libs, hey, a new version of Alsa-libs. Let's quickly build Alsa-libs. And again, so emerge prints that, and Alsa, or actually let's emerge depths none of Alsa-libs. Alsa-lib. Let's see how accurate, just for the test, that probably should build famous last words. Let's see, estimated 11 seconds to build our head, like 8 seconds. I mean, it's not that bad, right? And this is even I would say that's usable, right? Leave in the comments below. Is it usable? Is it amazing? Are you happy? Is that the last drop? Like, and by the way, yeah, tomorrow we will code even more stuff like we do here every day. So some code a day keeps bugs away. And how accurate, it's like, yeah, this was 25, so yeah, this is 25% of bin utils. That is, this will, even with a new dynamic, or will it change? Did I had, well, probably did I had 10 to 100 or so? Yeah, it probably will not change. That is probably accurate enough of 11. And this is also why this is off, right? Why is this off? Not only we estimate a 90% parallel build phase, plus this is quantized in percentage of steps of 5. In my opinion, accurate enough, and certainly like it serves certainly to a warning, like if you merge stuff on an SJ Octane or O2 or Raspberry Pi, it's like, hey, it will take 1 hour or 2 hours or a day. It's like, yeah. Yeah, if this is not there, we can't guesstimate it. By the way, let's let's do one thing, because I need to fix it anyway, and 23. How much dedication efforts? It's 20 freaking 3 hours local time, and I need to stay awake with Mate tea. Let's test one thing, which is my guesstimation here of, did I use cat? Let's delete the reference time. So until you have a reference time, T2 will not print it, right? Because we have no reference time, right? Let's see, I thought I implemented that it would store the reference time for the first build. So historically, T2 would only store the reference time for bin utils, but I realized normal people are not even advised to build bin utils because it can break, or I probably have to fix it because currently it probably will break due to the LTO plugin. Like the moment bin utils installs its new libraries, then it unfortunately will relink its bloody shared libraries with libtool, and then the relinking will not work anymore. So I believe currently in-system building home source probably breaks bin utils, which sucks. Probably need to fix it. So yeah, and also you don't want to build bin utils, right? If you build on an SJ Octane or Sun Ultra Spark gigahertz even or whatever, and bin utils take 30 minutes on a halfway decent vintage system, of course you don't want to rebuild bin utils unnecessarily, right? So did this? Oh, it did work. So, but it is way off though. 2 seconds is way off. Why did it not previously? Maybe I previously used a package where the build time was too low. Okay, it does estimate that, but it is somehow too inaccurate. Why is it that inaccurate? All right, maybe do we need? No, we don't need to factor in the parallel build phase. Given that it was, I think, probably the math is off there. So much debugging your math live on YouTube. That's also the wrong file. That is here, estimate initial reference time from in-system emer for in-system merge. I believe this could be more accurate if I mean, it estimated the ALSA lib time quite accurate, so I would think it should estimate the bin utils time, because we need to recompute that to, oh darn, did I not? No, I did set, darn, wrong line. If I do this in the middle of the file, it will of course not work. But could we already see probably, where do we have? Probably reference time 25, and this build in, no, I guess that actually, so this is the time we used to build. And okay, we just clobbered that though, but that probably, what does this print? No, this is actually what we guesstimate. That looks correct to me, so why does the reverse estimating that is so off? Should this not be close, or is it simply the inaccuracy? So, divided by 25%. So it's 4 times that. Strange. Probably there's a very good reason why it's not more accurate. Yeah, so I guess it's accurate enough for today. I wish it were more accurate, but it isn't. If you see a significant typo in that, okay, fine. If you see typo in that or want to improve the math, leave in the comments below. Maybe it's simply not possible to, whatever is going on there. What would it say for, I mean, now our time is off. What was the time I deleted the address to? Oh, no, I don't have it in there anymore. Like, yeah, maybe don't do strange stuff live on YouTube. And, oh, I don't wanna. Wait, what? Ah, right, we didn't save it right now. Ah. Very clever. Okay, fine, I only wanted to. What was even our reference time? It for sure was it. So 25,000 something. Yeah, something like that. Eight seconds, yeah, something like that. What would it say for, did I rebuild Emacs today? Maybe I did. Emacs 6 seconds. Is this cache file just so old? I believe Emacs builds a little bit longer on this horizon. 20. 2023. Yeah, some more investigation. Anyway, the infrastructure is there. It is in principle there. If you try this and it's too accurate or like ISA reported, and the most we prefer, patches welcome, right? Patches preferred. Also, we added added tree setter today. One of our new developers. And yeah, this should add, basically, let's, by the way, try that for, okay, that is way off. Why is this so much off? Okay, probably because it builds in, maybe for the Linux kernel, I mean, this is certainly, maybe we can't do it much more precise because for the Linux kernel, probably the 90% factor is off of 90% probably. It anyway will be off for non-GNU autoconf packages because previous video considered harmful and GNU autoconf packages in general have such embarrassingly long serialized configure time. And it will be less off for CMake stuff, Meson Ninja, and the Linux kernel doesn't have such a long configure. It has a configure and some pre-processing, but probably more like 2% or so. So yeah, maybe also additionally the cache file is not as accurate as it could be. Yeah, 2023. Yeah, so much to that. Yeah, so it is there. We will see, so we will further fine-tune it based on our own findings and your feedback. I hope you enjoyed this and learned something. As always, don't forget to share, like, and subscribe. And I hope to see you soon for the next fun stuff to come. Just some spring cleaning. I just realized there were some interesting comments that I wanted to quickly answer. One, got a test estimate on GCC on P3. Yeah, let me know, and I will also basically what we could do, or like could do, should do, rebuild, like basically rebuilding, installing a new VM, like we usually do, and rebuild all the obvious cache files. For example, with build time 0, right, and fine-tune. So the thing is, everything will be a win-win, right? It will improve dependencies, it will improve build time estimates. So yeah, and also I will unpack the P3 the next days, or maybe next week, not next days, but maybe next week. and do PS3 stuff. Other Christian, could you show us install T2 on Mango Pi step by step? Yes, I have such videos planned. It is just I have too much to do, right? So the more you subscribe, the more direct income we generate to finance even more. The more 8 hours, the more 16 hours a day I can work on this and even hire students or interns and other full-time developers. So I will add magazines, right? I have planned how to basically, there will be also an article sometime soon meaning months, right? I cannot work all night because it's approaching midnight. There will be articles, I've planned an article like how to, from some crazy board like Mango Pi or Orange Pi, like how to, because you need the matching kernel, right? How to Frankenstein another image, like how to merge T2 with a generic ARM or RISC-V image and add those other kernels for the easiest instant use of such boards. Mango Pi specifically, the problem is adding all the boot code, right? Mango, the all-winner stuff has, like all the other all-winner stuff, has very specific low-level requirements of where it loads its bootloader and stuff. So that will be challenging to support, like all the other 2013 Linux distributions have challenges to support all those specific images. So yeah, we need to see how to best directly support Raspberry Pi, Orange Pi, Mango Pi images. But yeah, articles coming or video and stuff. And also other question from Carlo, Power XL still work? Yes, it does work. I should do more. It's just not, it's more like collecting interesting museum pieces and future dedicated YouTube videos, right? The last 3 years, due to various reasons, I could not, I mean, with all the excessive, you probably realize I put excessive time in our open source projects that we also use for work and are of course 100% like much more open source than Red Hat and stuff. But I cannot play more like with P3 or Power XL. And I collect them mostly because they're interesting and I want to see it. And also like then I have them, right? And I collect them now, like I usually buy them for affordable. Affordable at times can still be €100. Because I have some eBay searches running to build up our archive in my company, right? And YouTube. So there will be dedicated videos, right? If you find this stuff interesting, share, like, and subscribe. There will be dedicated videos coming, right? Just like I need to keep our company and T2 running, right? I cannot make dedicated video for like, hey, here's a detailed one of a Power XL. There will be in a year or two. Until then, we get our T2 Linux in perfect shape. And I collect it now because otherwise they only go up in prices, right? I don't want to buy a Power XL in 3 years for $1,000, right? If I could get it last year for, I don't know, $100 or maybe $80 or whatever it was, that's amazing. I regularly don't want to overspend. And I didn't buy, like every week I don't buy something. I'm not kidding, like I'm not, there was, Deck Alpha, I bid like 200 or so, and other people bid 400. It wasn't even a fast machine, right? What else was there? There was some other vintage stuff this week. There basically is every week something I don't buy because other people, maybe other YouTuber, I don't know, maybe the 8-bit guy or that doesn't computer stuff. There must be other YouTuber who bid even more, right? I might auction quite some stuff when it's affordable and useful and stuff, but there's also every week something I don't buy because, like, also the 5th or 7th time I tried to auction a Matrox M3D with Power VR 2, I believe. It's literally the probably 7th. But I'm not spending like 200 euro, right? It's absolutely crazy. For me, I mean, I don't need it. It's like, hey, we also don't need to kid ourselves. It's not that collectible, right? Like, sure, it's nice to have in the collection, like for 25 euro, but I'm not spending 200, right? I would pay 100, which I find already expensive for a piece. Is it PCX2? Power VR. It does not need to be Matrix, just the Matrix M3 is one of the most commons, probably. But yeah, I'm not spending 2, 3, or God forbid 500 freaking euro for a slow decelerator from 25 years ago. I mean, I could afford it, but I, out of principle, do not overspend all the stuff, right? I rather not overspend and buy another Ryzen or next year Threadripper or whatever, than like, hey, for this money, I don't spend on vintage stuff. I can literally buy a Threadripper, right? It's like... Anyway, yeah, welcome everyone. Some people are late. So yeah, stuff is coming. Maybe Patreon or send hardware, which someone did. Maybe you're the one who sends the hardware things again. That's amazing. And Devstock. DevDuck has an issue compiling ISL and bin utils. Have you tried? Yes, I tried recently. I literally built those two. I built a full, like previous videos. Should work. In T2, I'm not sure. Like here, maybe comment below or Discord or mailing list. It generally does work. So yeah, and patches welcome. See you next time. Probably should have dedicated Ask Me Anything streams. Always, if I tell another 7 minutes about vintage and retro stuff I didn't buy, maybe not the best. Video composition. See you next time. Probably tomorrow.